Good morning, all, or good day, or good evening, depending on which part of the world you're attending from. My name is Kumo, and I'm a course advisor based in our South African offices in Johannesburg. So thank you all for taking time out to join our webinar today. And I'd just like you to quickly pay attention to the slide that's on your screen right now. Could you please kindly turn off the notifications and sounds? This is just to limit any interruptions or disruptions that may come in. So today's topic is our lecturer's insights exploring EIT's industrial automation engineering options. And it will be presented to you by Dr. Hadi Harb, which is our course coordinator, as well as our lecturer here at EIT. And we'll also have the privilege of getting to listen to Mhlonipheni's insights as well as a student at EIT. Now, for this webinar, we will send you a copy of the slides and the video recordings, as well as the certificate of attendance. So if you could stay long enough till the end of the presentation, I will provide you with the link and the code, the QR code rather, for the certificate of attendance, where you'll just fill out a short little survey, and then you'll be able to receive your certificate of attendance rather. And just to tell you a little bit about EIT, for those of you that's your first time attending one of our webinars. So at EIT, we are basically dedicated to ensuring that you receive a world-class education and gain skills that you can immediately implement in the workforce, right? And so that's aided by the fact that we are an engineering specialist institution with industry orientated programs, and that's made evident by our world-class Australian accredited, this word always gets me, education. And so that's made possible by our industry experienced lecturers, as well as our unique delivery model. So all of this is highlighted by the ratings we have received, making us the #1 Australian provider for students' overall satisfaction in postgraduate engineering programs, as well as being #1 Australian provider for graduates in full-time employment for undergraduate engineering programs. And we are top 3 as the Australian provider for quality of education experience for undergraduate engineering programs. And we also numbered 3 as an Australian provider for student support for postgraduate engineering programs. So all these ratings are made evident by the awards we received last year. And as you can see, we received the 2024 Australian Export Award for International Education and Training, as well as the 2024 West Australian Export Award for International Education and Training. So I will hand over to our presenter, which is going to be Dr. Hadi Harb, and he will take you through today's webinar. Once again, thank you all for your time. Dr. Hadi, if you can take it.
Great. Thank you, Kumo. Hello, everyone. So let me just take control, and I'll try to see if I can move through the slides. Let me just check. I can move through the slides, right? Is that correct, Kumo?
Yeah, perfect.
Okay, perfect.
Thank you.
Great. So welcome, everyone. My name is Hadi Harb. I'm based in Barcelona, Spain, and I am a lecturer at EIT, typically teaching in the industrial automation area. So what is industrial automation? Industrial automation is whenever we want a certain machine a computer typically, to make decisions instead of having a human, necessitating a human making these same decisions. Okay, so it could be the decisions could be done like completely automatically, or the machine will do them on their own, or it could be with assistance with a human. So there will be a human in the loop. More and more, we are oriented towards decisions made by the machine, and the decisions made by the machine are becoming more and more complex, like things that in the past we thought a human should be making them because these are like kind of complex decision making processes that should be followed. Machines are starting to do just that, as you know, with the advent of AI. Now, if you look at where we are in the industry today, so industrial automation is applied on the industry. You have industrial processes. Where we are right now, if we started with like a categorization how industry developed, Industry 1.0 was the use of steam engine. This changed the world. Relying on power coming from a steam engine is not the same thing as relying on human power or animal power. Just imagine, before that, people had to rely on either human or manual power, or sorry, human power or animal power, and then there's this shift to steam engines. You could produce much, much more power. So this is what we might call Industry 1.0. Industry 2.0 was with the introduction of electricity. Electricity, again, made a huge shift because steam engines, you needed to build a steam or to use a steam engine in your factory or in your plant in order to use that power. It was quite intensive to do, difficult to manage. It's not like it wasn't democratized, like everyone can do that. With electricity, things are much easier. Electricity is produced in a certain power plant that could be far from the factories that need to be using this electricity, and with wires, you use them, plug in a motor, and then that motor starts spinning. So it's distribution. Distributing power became much easier with electricity. So this led to applications like an assembly line that needed electricity for this to happen. And with assembly line, again, manufacturing became faster, better, and cheaper with the assembly line. Because before that, people, if they were to build a car, for example, every car was considered like a project on its own, and you need artisans who will be working on that car. So the quality of the car will depend on the artisans. It will take time. You don't have the same repetitive processes, so you wouldn't expect the same types of cars to be produced, and it was expensive. With the electricity and then the assembly line, this became clearly much, much more streamlined and easier. And then third industrial revolution, or the version of industrial revolution, is with the introduction of computers. So it started with microprocessors that were relying on semiconductors, but with microprocessors, computers were able to be used, and like many industries today are still in, or so they are Industry 3.0. You do programming, you ask a robot to do some action for you. You program, for example, on the conveyor belt, you can program the sequence of operation on the conveyor belt. So it's a mix of computers with the industry to do the control. We might say that today we are more in Industry 4.0. Not necessarily like every company is, or every manufacturer and plant are in Industry 4.0, but everyone is oriented towards that, Industry 4.0. And how do we categorize, how do we think of Industry 4.0? It's the collaboration between machines, between humans. It's the communication that could be wired or more and more wirelessly. And it's the intelligence in every device that you have. And this is what we would call here the Internet of Things. So things that are smart. They can connect to the internet, so they can be part of a network, they can collaborate together, and they are necessarily smart. They have a microprocessor in them. They can do computing And this is needed for them to do this connection on the internet. So today, we are in this world of Industry 4.0, where we deal with things that we would call like cyber physical systems. Cyber physical meaning you have a physical representation of a machine, for example. It's in front of you here. There's software that's running that machine. And more, there's a virtual copy of that machine. It's a twin, what is called a digital twin, of that machine on a computer. So you are seeing the machine in the real world. You are seeing this model of the machine as a digital twin on a computer. You can use your model on the computer to make predictions, to improve the operations of the machine, and at the same time, the machine is providing data or sensors data to the computer so that you observe on the computer the real state of the machine. So we are constantly observing the real state of the machine. And when I say a machine, it could be like the complete factory. Okay, it could be a boutique. This is a system. And we are able to make predictions, make better decisions, and act on the physical world, physical environment. So this is typically where we are. Industrial automation fits in this evolution of the industry from 3.0 to 4.0. Now, in 3.0, you had industrial automation. You have industrial automation. It's about programming computers to make decisions, to automate operations, like to regulate the temperature in a room, to regulate the pressure in a boiler, to provide the right sequence of operations on an assembly line automatically by robots. This is Industry 3.0. Industry 4.0, pushing things further, as I mentioned, with more predictions, more artificial intelligence, and more optimization. Jobs in the world around this industrial automation. In fact, here are some studies that will show you like how many new job opening will be. We can expect it to be huge. It is already huge, and you expect it to be always on the rise. Because if you think about it, how the world is evolving, it's evolving towards more intelligence, more automation, and this will bring costs in general down, like producing food, producing medicine, um, producing houses, construction. All of this should be benefiting from automation to become a lower cost or getting higher quality with the same cost. So it is a trend. Everyone needs that. Hence, there are a lot of job opportunities in this context of industrial automation. Now, okay, so when do you see application of industrial automation? So where one can work in industrial automation? You have mechatronics and robotics engineering. This involves aspects of industrial automation. You have industrial engineering, control engineering, electrical engineering, process engineering. Process engineering are those engineers who deal with in processes like chemical processes, like if you produce pharmaceuticals, for example, dairy processing, so food processing. These are process engineers who will be designing the process, and then they need to control that process automatically. Hence, you have process engineers with control engineers. Industrial communication, it's part of and used by industrial automation. Oil and gas instrumentation, and IT and OT security conversions, where information technology, operation technologies, they are converging together. Because when we say intelligence and IoT, this term that I mentioned, Internet of Things, devices that can connect to the internet are immediately going to be open to attacks. So we have the advantage of being connected, but at the same time, the disadvantage of being open to attacks. And you need engineers who are able to deal with these issues of cybersecurity at both levels, for the IT level, but also for OT level. Okay, let's just imagine an attack on a plant. And these are things that happen, okay, like attacks on specific plants in a specific country to make damage, to make real physical damage. Hence, it opens opportunities for people to work there in terms of the control and the minimization of such attacks. So these are areas where you would expect to work as an industrial or automation engineer specialist. Now, how EIT deals with industrial automation, with this important sector, and what EIT offers. You have courses that are linked to industrial automation, from professional certificates of competency that are for 6 months up to doing a Doctor of Engineering. And in terms of, these are in terms of durations if you want, going through advanced diplomas, undergraduate certificates, graduate certificates. They could be in 6 months or a year, graduate diplomas, Bachelor of Science in Industrial Automation, Masters of Engineering in Industrial Automation, and the Doctor of Engineering, which is open because a Doctor of Engineering, you decide your own topic, including we have many thesis projects, so doctorate projects that are in the context of industrial automation. Okay, so it's a variety of choices that are available for someone who wants to take, during 6 months, a professional certificate of competency, get introduced to some aspects, or be very specific, like hands-on experience in a specific aspect in industrial automation, up to doing research that is applicable, which is in Doctorate of Engineering. Okay, in professional certificate of competencies, what do we have as relevant certificates? You have professional certificate of competency in digital twins and simulation monitoring. Professional certificate of competency in programmable logic controllers and SCADA systems. The SCADA stands for supervisory control and data acquisition. So being able to supervise a process remotely and do remote control on that process. Professional certificate of competency in industrial Internet of Things. And then in safety instrumentation systems for process industries. And then certificate of practical troubleshooting and problem solving of PLCs. PLCs, these are programmable logic controllers, very commonly used controllers, and SCADA systems. And a certificate in instrumentation, automation, and process control. A certificate in industrial control systems, cybersecurity, in industrial automation engineering, in industrial data communications, certificate of competency in this standard here, IEC 61850. This is used in substation automation, so electrical engineering. In control valve sizing, selection, and maintenance, and in Allen Bradley control Logix 5000 PLC platform. So this is for a specific platform for controllers called Allen Bradley. So these are at the professional certificates level. Advanced diplomas that are relevant to industrial automation, you have the Advanced Diploma of Industrial Automation Engineering, Advanced Diploma of Electrical and Instrumentation Engineering for Oil and Gas Facilities, Advanced Diploma of Electrical and Instrumentation Engineering in Mining. Then you have undergraduate certificate in Engineering Foundations, undergraduate certificate in Industrial Instrumentation and PLC Programming, and undergraduate certificate in Industrial Automation Engineering. Graduate certificates you have in Industrial Automation and Machine Learning, in Chemical and Process Engineering, in Industrial Automation, Graduate Diploma of Engineering in Industrial Automation, Mechatronics, and Internet of Things for Engineering. And then you have engineering, so Graduate Diploma of Engineering in Industrial Automation. Now, as we've mentioned, we have also the Masters in Industrial Automation and the Bachelor of Science in Industrial Automation Engineering. Now, what are the trends? So some important trends, most probably are aware of the majority of these trends. Internet of Things and hyper-connected world. We are seeing it around us. Everything you expect it to be accessible to on the internet. Okay, like today you buy a tag, you add it on a device, you put it in your suitcase, and then you can track that suitcase everywhere around the world, right? So we are expecting intelligence now everywhere. So this is Internet of Things, hyper-connected world. Artificial intelligence and advanced automation. Everybody's talking about AI today. So AI is not just the use of something like ChatGPT to answer questions. It has also many other applications, in particular in industrial automation, like to do advanced automation. So not necessarily, as I mentioned, as a large language model, like you ask a question and it responds, but make the right decisions, optimize. So the use of AI. Machine learning, which is a subset of AI, a subset where we build a system that will learn on its own from data. And the more data you give it, the better it gets. This is also a big thing in industrial automation, including, we'll mention it, one of the units that we do in the master's is about applying machine learning to solve industrial automation problems. Use of smartphones as a tool. In fact, you have a lot of instruments where you use your smartphone as the interface to that instrument. Renewable energy, battery storage. You have virtual, so clearly renewable energy is a big thing. And there's a lot of industrial automation, by the way, around renewable energy and battery storage. Virtual and augmented reality, collaborative robots, and cybersecurity and cybercrime. And as I mentioned, when you make devices smart and accessible on the internet, you also have to deal with cybersecurity. So there are openings there. So these are important trends that we are observing today. Now, how these trends are linked to specific courses we deliver at EIT. The digital control trend. Okay, digital control meaning using computers to do control. Computers, they could be a chip like this. This could be a computer. You would call it a microcontroller, to a large server that is doing the control. So when we say digital control, it's a complete range. So the courses, you have industrial process control systems, MIA 503A, industrial instrumentation, how to select the right instruments, advanced process control, which is a continuity of industrial process control systems with advanced topics. Then machine learning and artificial intelligence, you see them in MIA 605 unit. It's a master's unit. So when you see here MIA, these are master's units. Machine learning for industrial automation, then CNQ, this is the professional certificate of competency in machine learning and artificial intelligence. BIA 206, this is bachelor, data analytics and artificial intelligence. Cyber physical systems and Internet of Things. You have CII, which is a professional certificate in industrial Internet of Things. CHH, a professional certificate in big data and analytics in electricity grid. CAO, for the professional certificate of competency in programmable logic controllers and supervisory control and data acquisition systems. Robotics and mechatronics, the courses, DMC, Advanced Diploma of Robotics and Mechatronics Engineering. And in that diploma, you have also for example, a machine learning module also. BIA 308, Industrial Robotics and Mechatronics. Cybersecurity and modern industrial communication, you have BIA 307, IT, OT, cybersecurity, BIA 207, modern industrial communication systems and protocols, and MIA 510, industrial data communication. So this is a master's unit, and the B units BIA are bachelor, and CID, which is a professional certificate of competency in industrial data communications. Okay. To wrap up what we do here, just to show you examples, we'll be seeing important terms that we've mentioned that are part of this trend in industrial automation. And for each one of them, what you would expect to do, what kind of software or hardware you will use and you'll learn at EIT. For example, for programmable logic controllers. Programmable logic controllers, they are mentioned in Masters of Engineering and Industrial Automation, and in these courses, GCIA, CPLC, that are graduate certificates, and also in undergraduate courses. So what's a programmable logic controller? It's a type of controller very commonly used in the industry. It's a computer, and you can use it to control a process, like control a machine, control a robot, control a set of robots, and you program it. So in the different courses at EIT, students learn how to program such controllers. There is one of the labs, remote labs, which is a lab that you can access from wherever you are on the internet. There's an actual physical controller connected there, and you can check its operation. And what is done typically is via simulation. So there's a creation of a virtual controller, and students will learn how to program that virtual controller. And the next step will be just downloading the program on the physical controller is just a small step, but the essence is covered in the simulation. SCADA, Supervisory Control and Data Acquisition Systems. This is, for example, here an interface that will show you what's a SCADA system, like where you create an interface for operators to supervise a process. You will be showing them like tanks, you'll be showing them motors running, what's their speed, what's the temperature here, what's the pressure there, alarms. So there's a software that's called SciTech SCADA that is introduced to students, and students will be able to work with that software, check an interface, create an interface, and see how it works. Then you have machine learning. Machine learning, for example, on the left, you see here building a neural network using a software called MATLAB. You might be familiar with that. It's a great software used by engineers and scientists to do designs, to do simulations, etc. So it has this use to build neural networks. Now, what are neural networks? These are models used in artificial intelligence systems, machine learning systems in particular. So students will learn how to use it in order to make predictions, in order to detect faults in a machine, and many other applications. So this is on the left. On the right is the same tool, actually MATLAB, that's used in designing controllers. Controllers in the context of what's called process control. So process control is what you use to control, for example, the pressure in a boiler to ensure that it's always within the right level, and the controller will be constantly regulating the amount of fuel being injected and the amount of water being injected in order to produce the right amount of steam and keeping everything like tightly within the limits of temperature, the limits of pressure, and the flow. Okay, so this is called a process controller that you will design. There's a lot of theory behind process control, and it's called control theory, and this is taught at EIT in several units. And the software used is MATLAB. There are other software tools, but mainly MATLAB is a great tool for designing and doing simulations before going to the implementation on the physical controller. Okay, here IoT, so Internet of Things. In the Bachelor of Science, you have IoT being taught, and there's an example of a lab where students will be able to see like how to remotely switch a certain lamp over the internet. On the right here, you have an example of a software, another software seen in machine learning. It's called Weka software. And here in the figure on the right, we are seeing predictions of electricity demand, so forecasting electricity demand by learning electricity demand, so the patterns from the past. We can use this data to make predictions of the electricity demand in the next few days or so. Okay, so this is something that is taught, and in one of the units, actually, the students will be able to do that. Like they will have the data, they will create the model, and then they will be making the predictions. Okay, so this is it from my side. Thank you, everyone.
Thank you so much, Dr. Harb. And then next we've got Mhlonipheni, who's a student at EIT, and he'll be basically taking you through his experience, what he's learned, and everything else that entails being part of EIT. Thank you, sir. You may go ahead.
Thank you, Kumo. Can I take control?
Yes, please.
Okay, please tell me if I'm able, let me see if I'm able to move right through the slides.
That's perfect.
Okay, good day, everyone. So my name is Mhlonipheni Nkuta. So I am a master's student in industrial automation. So a second year student. So I'm currently based in South Africa. So my journey with EIT, it spans actually many years ago, where it was actually through a colleague who actually took up a number of courses with EIT, and drawing from his experience then in terms of what he was able to actually do from the knowledge that he has gained taking up those courses. So that's when I actually developed the interest to also in the future want to actually study with EIT. So a few years later, then as I actually wanted to enhance my knowledge after I've attained the necessary experience in the work environment. So as I was sifting through the number of courses that EIT had, I actually stumbled across the Master of Industrial Automation, where it actually met the needs that I was looking for at the time, with the variety of modules that actually cover a wide spectrum of the knowledge that I actually needed, so that it can also complement the experience that I had attained in the environment. So the experience that I've had so far, it has been good. And this is simply because the delivery of the material and also the lecturers have they've got the necessary experience. They actually know what they are talking about, and also during the classes as well, they make the material a lot more understandable through demonstrations, as well as the assessments that you actually get given. They are a bit more practical. So since I'm a practical person, so that for me, it has actually been very good. Um, um, and also the resources as well, they are very good. So they are actually world-class resources, and everything that you need, you can actually find to be able to be successful in the program. And as well as when you have queries as well, the turnaround time is actually quite good. It's quite short. So in terms of the response time and the feedback that you get is actually fair, which helps a lot. So how do I find studying online with EIT? So studying online, it has been good. I basically appreciate the flexibility that actually comes with studying online, simply because you have the work life and you also have the personal life. So balancing that with the online material, especially the recorded lectures, which actually allows you to be able to catch up when you have actually missed the lectures due to other commitments that one might have. So that actually gives that level of flexibility to be able to catch up and not fall behind. So what I appreciated most is basically the fair feedback that you get from the assessments, which actually builds you and also highlights areas that you actually need to work on, which is actually quite good. So have I been able to apply what I've learned directly in my current job? I would say yes. So the practicality of the assessments that you get also allows you to innovate. It allows you to also be able to be in a position where you are able to challenge the status quo. You are also able to tackle problems a lot more efficiently. So that's one of the things for me that has been very good. The practical aspects of it. Actually, the balance between the theory and also the practicality of what you apply from what you've learned from the theory. So that has been exceptional. So one of the most important things as well for me is being able to be in the position to also impart that knowledge gained from from the material, sharing it with the engineers in training or anyone that actually needs a level of education. So that for me has been very beneficial to be able to be in that position to also share the knowledge that I've gained. So something that I was nervous about before actually taking up this journey is because it's an online program. Also, you have commitments, work commitments, you've got life commitments as well. So that's basically what I was nervous about, is that it's balancing all those aspects of my life. And I found it to be actually manageable. The workload, yes, it was substantial, but having proper planning in terms of time, it actually helped quite a lot, which kept that balance between those various aspects. So, but one thing that I'm sure that everyone knows of is that taking up an academic journey, and it is a sacrifice on its own, just like any other thing that you might actually take up in your personal life. So, what was good is actually being able to also catch up on the material. Although, like, taking up this journey is a sacrifice, but I think it's a sacrifice that is worth taking. So has EIT helped you feel prepared? So it has helped me to feel prepared in my career path as well as in my current role. It's simply because, like I've mentioned, the emphasis on the practical aspects for me was actually much more important, because then I'm able to apply the knowledge that I have gained during the lectures. And it has, for most part, been, like I've mentioned, the practical aspects of it. And also the thing that I also found very, very good was the ability to self-reflect. So the assessments, they put you in a position to actually indicate, to give a genuine account of how you have actually experienced your journey throughout the module, and to highlight certain areas where you have felt you've encountered challenges. And that, I think, it's also very important also for the assessor to understand in terms of how to better improve and understand the challenges that one has encountered in completing a particular task. So that for me has actually been good, to actually give that genuine reflection of how I've experienced that particular module throughout the time. So the online tools, platforms, and technologies you use most. So what I've actually used most, it's MATLAB and Python for some of the modules, like machine learning, as well as other modules as well. So these are some of the tools that also apply in the workplace, since I'm actually in the industrial automation space. So they are not so distant from the work life as well as the academic life. So that also has been, yeah. So those are the tools that that I've been actually using most. So what surprised me about studying with EIT, it's the level of professionalism, and also the lecturers, they actually know what they're talking about, and the delivery of material is actually quite good. They go through the extra length of explaining the concept in a simple to understand manner. Some of the material they've got a lot of, for example, mathematics, where for most it would be a thing of, I've seen that thing probably 10, 15 years ago, but At that particular time, the lecturers actually go through that process of actually explaining in an easy to understand manner, without taking away also the responsibility of also going back and also reading up and also empowering yourself as well to be able to understand the material and be able to actually progress through the program. So as my parting shot, so the advice that I would give to someone who's thinking about taking an academic journey or a journey with EIT, I would say the institution as well, they do actually go through the lens to assist you. But in general, taking up this journey amongst other things that might actually be happening in our lives, it's like I've mentioned, it's a sacrifice. So but it is actually a sacrifice that I feel that it's actually worth taking, simply because of the contribution that it has in terms of your growth, and the knowledge that you gain is actually it's not only just theoretical, but it's practical. It's something that you can actually apply in the workplace. And also the resources as well that EIT has, it just makes the journey a bit smoother, um, as well as the support system. So as well as the institution itself, they're able to actually give you the necessary guidance that is required for you to actually be successful. So I would actually say that it's something that is worth taking, and if it's something that is actually in line with your needs, I would say that it's something that you really need to look into. So this is where I end, Kumo. Thank you very much.
Thank you so much to both you and Dr. Harvey. This was very insightful, and I can tell that you are quite comfortable with EIT, as most of our students are. And thank you so much for your time. And thank you to the attendees for actually making time to be a part of this webinar. Like I said earlier on, you will be sent um, the link and the copy of the slides, as well as the link for the certificate of attendance. So we do have a competition running up to basically showcase your creativity and humor in a video format, and you could get a chance to win $2,000, and then the top 10 runner-ups will get $100. So this needs to be a 3-minute video with a little bit of humor, basically showing your creativity on a traditional tool. I hope that makes sense. So you could go on our website as well to take a look at this and just see what it all entails. And this is our QR code and the link for the certificate of attendance. And in the chat box, I will provide you with the link, as well as the other links for how you could reach out to us and so forth, and as well as the courses we're offering at EIT. Are there any questions from our attendees that we could possibly answer right now? If you don't mind, you can type them in the Q&A box, or if you don't have that function on your Teams, you can also just pop them in the chat. Well, I'll give 5 minutes for questions, and then if there aren't any, then we'll wrap it up, okay? So we'll have 5 minutes for you guys to think of any questions and type them in the boxes. Thank you. Okay, so I see here that Edgar has asked a question and said, I was asking the projects presented to you can be in prototype stage. I'm not entirely sure what you mean by that, Edgar. Maybe Mhlonipheni or Dr. Harvey, can you guys maybe see what Edgar means? Edgar, could you maybe try elaborating on your question? Marvis, above this chat, I have put the link so you could book a call to speak to one of our course advisors who can then help you explore your study options. So if you could just maybe click on that link and check a time that's suitable for you in your time zone, and then we'll give you a call, okay? Yes, Edgar, the competition is for everyone and it should be 3 minutes. So if you could just quickly go onto the website and you'll be able to see the competition. If there aren't any further questions, then we could wrap it up. And once again, thank you all for attending our webinar today. I hope it was insightful for you guys and you've picked up on a few things that might interest you. And by all means, feel free to go onto our website and check out all the other courses that we offer. If that's it, then we can call it a day. Thank you all. Goodbye.
Okay. Thank you, Kun. Bye-bye.
Welcome.
Thank you.
Bye.
Thank you. Bye bye.